Okay, so I'm here to talk about Tesla coils. I know something about Tesla coils not only from electronics school and physics in college, but I'm familiar with, at the time, the world's largest Tesla coil. So if you could see this picture, so the top toroid is the output of the Tesla coil. This is the electronic arcing that comes from it. Okay, so you see the actual primary coil is the bottom toroid. This is just how the world's largest Tesla coil was stored. So you see the bottom Tesla coil with they use copper pipes as wire, and the primary of a coil, depending on if you're looking which way you're looking at a coil, the primary, because electricity doesn't flow one way, electricity flows two ways. So the primary coil would be considered the starting point. So let's say you have 2 turns on the primary coil, and if you have 4 turns on the secondary coil, you're going to step up your voltage, doubling it. So if you notice, the secondary coil is a tower with, they use steel cable winding around a cylinder, like 20-foot tower of steel cable in a coil. So the voltage was brought up a lot, and then it discharged through this toroid. So you could see, and it's coming out of both sides of the discharge toroid. That's a torus, the top donut. And then this is they're just meters monitoring the voltage. I believe there was a variable transformer. To a certain extent, you can add or subtract some of the turns, a variac. But so the frequency was still 60 hertz on that particular Tesla coil. And you don't want to mention Tesla coil in mixed company or a place where you think that there might be eavesdropping going on. So that's pretty much why these things are discussed in back rooms and whatnot. There is the old saying, for every 3 people, 1 person is a federal agent or is going to be flipped and forced to testify about what you were talking about, the Tesla coil, right? So the reason I bring up these Tesla coils is we have this ancient 20,000-year-old transformer that was found in Kosovo. Okay, so you see that's a schematic representation of a transformer. The left coil has 4 turns, the right coil has 8 turns. That's going to double your voltage. So the one on the left is looking as the primary. The one on the right is your secondary. It's a step up transformer. It's going to double your voltage, but your current goes down. So whatever you have in between there, iron or air, you're trying to reduce the counter EMF and the counter EMF. The counter EMF is the loss of the transformer. So you're going to put iron, powdered iron, to transfer the energy completely across that transformer. So the Tesla coil I showed you at the time was the world's largest Tesla coil. It was advertised like that. It was put on a show. It was taken around for shows. And I was in a voluntary crew for that Tesla coil. It was used in parties and music shows. It was advertised as the world's largest Tesla coil because there were no challengers. As far as the builders and the maintainers believed, and the promoters of the show, it was the world's largest Tesla coil. And there was nobody disputing it. No one thought that there would be a dispute for it. And perhaps there was larger Tesla coils. So the point of it is that that's a pretty big Tesla coil, right? We're working on 60 hertz frequency. So the number of turns of your coil for your primary and secondary are also dependent on your frequency. You just can't put a random number of turns of a coil or the diameter of the wire. So you could see that Tesla coil was using copper plumbing pipe. So that's a black cat. That's just the cat that we had. And so the arcing of this Tesla coil was used as a FX, special effects, or something like that for shows. There was no practical purpose for that Tesla coil. So if you were to have the receiver, whatever, maybe a fluorescent bulb, so that would light a fluorescent bulb maybe 20 feet away. So it wasn't designed for RF, radio frequency. It probably would have gotten more attention than it did if it was in radio frequency range. It would have showed up on probably someone's RF system somewhere as noise, right? So let's get into the Kosovo transformer. Okay, so this is the first picture of the press release of the Kosovo transformer. you see the short coil there, and it's going, so the Tesla coil I just showed you, the turns were horizontal and they used the air. This coil, they're vertical, going around a toroid, and then there is in the middle of the, not only is there something in the middle of the toroid the coil is wrapped around, but it looks like there's some kind of, literally like a spark plug coming out of the center of the toroid. And whatever material they were using to hold the coil together has turned to stone, mineralized. And so the process of turning into a fossil is where minerals are exchanged with other minerals as time goes on. So they're saying it's 20,000 years old. I'm not sure what the dating is of how long it takes to turn into a fossil. And then this looks like a horseshoe magnet. Okay, so this is the second picture that was released of the 20,000-year-old Kosovo transformer. So there again, so this is lying on its side. It looks unusual in that its purpose is undetermined. So we have, this horseshoe magnet, or so the insulator probably turned to stone. They're not using stone. Whatever materials it was has turned to stone, so ceramics, right, or something. So you look at this, and if you're trying to operate a Tesla coil, it's something different but related to a Tesla coil. And the diameter of the wire. So this is not a speaker. This is a coil that is in the high-powered RF range for some reason. And so judging by how many turns there are in this coil, we could probably get the frequency of it, of this coil. Okay, so this is the third picture of this coil, and it looks, so from here it looks like it might have been mud had come upon this device, and it sat in mud, a flood or something. You could see the ceramic insulator that looks kind of like a giant spark plug there. So it might have been that there was wire around that ceramic insulator on top of it, right, thereby forming the transformer. It just looks like some sort of weird device that, we have no idea what the hell this is, what technology was attached to this, or what it could have done, because it doesn't look like a part that we have right now in today, in modern society. So here we have another shot. It's a close-up, and the toroid has something in the middle of it. Again, the coils are vertical around the toroid and inside the torus. So there's a torus inside the windings of the coil, and then inside that torus there is this insulative material and then a ceramic that's turned to stone. Looks like where wire was wrapped around it at one point. That would form a transformer, because a transformer has two sets of coils, right? Or something. Look at this. This is the side of it. It's broken, or it has, when it was mineralizing, it formed around something. This is another view of this fossil. So the whole thing probably would have turned to a geode in 1,000,000 years. The mineralization is forming around this thing, and what is the? It's huge. Like so, the transformers for your laptop or iPhone, in comparison to this, is a lot different. Obviously. So here we go. This is lying on the side. And so, very strange. So when you see a ceramic plug like that, you automatically are thinking high voltage, because look at what high voltage is your spark plug is. It's using to ignite the gasoline in your car cylinders. So it must have been a very high voltage, high frequency device, and they're using this is right where the counter EMF would come in for a transformer, which is weird because we don't use counter EMF. So here is apparently the 20,000-year-old quick disconnect, and so this diameter is more than 110 volts AC, more than 220, more than 440 volts that we use today AC. And with this, the person who found this is decided for himself that this is a 3-phase transformer, because that's how he thinks it could operate. And he's pointing out here the disconnect. Here we have another shot. It's edgewise. We don't know if this is the orientation of this device. It was like this. Look how it looks like a horseshoe magnet, which would be affecting the counter EMF of a transformer. So like I said, we don't use counter EMF for anything. We try to either ignore it, dissipate it, or make sure that our counter EMF goes back into the primary or secondary. This looks like they're doing something with the counter EMF and counter EMF. Very strange. And then this is another shot. It looks like somebody shoved a spark plug into a toroid. So you have problems with the modern thinking of electronics, of what this would be doing, because of all the electronics that I've seen I've never seen anything done like this. And of course, there could be someone that says, oh yeah, we work with those all the time. We have this application for it. I've never seen anything like this, or why anyone would even need something like this. It flies into the face of logic of what we think a transformer is, or even a coil, or what is counter EMF, what we're doing with it. Here we go, another shot of, because it's hard to determine what the orientation of this would have been when it's in operation. The coils are going the wrong way. And so another thing that could have been investigated is if the coils are going left to right or right to left. Well, at this point, it's so bizarre. You're winding a coil around a toroid and then putting a spark plug in the middle of the toroid. So this looks more like the process of how the insulators were fossilized. So the horseshoe magnet keeps coming to mind. They put a horseshoe magnet around this coil. So here we have the last shot. This could be the glory shot of this 20,000-year-old transformer. So there's the glory shot of the coil. We have a horseshoe around it that is an insulator. And the horseshoe's forming around the spark plug device. So you wouldn't just put in electricity in a device like this for the hell of it. There's something coming out of it. There's something going into it. The coils for a Tesla coil, I don't know if you could make a Tesla coil out of it, but that's what I think it is. An ancient Tesla coil. So here we have the picture of the Tesla coil. So you see this thin arcing, and then you see the thick arcing. So the thin arcing is what you get when you turn the variac. Fine tuning, so to speak. And the thinner the arc, it would go farther. And the reason why we don't have a science to this, and maybe are putting this to use, is because we are not thinking like the ancients. So the ancient transformer, to me, the ceramic in the toroid is the output of an RF antenna. Transmitting it in the air. So another thing about the transformer is that you could have information on your electrical power. Look at the information that's on our Bluetooth computers, text, video, sound, everything is on a Bluetooth or say an AM radio. So the ancient transformer, so there must be, what we haven't found is the control box for that transformer. It would have dissolved any kind of little components That huge transformer is turning to stone. Yeah, that's the it's ancient technology. They're saying 20,000 years. Who knows how long that transformer has been sitting there turning to stone, or what it was used for.